Welcome back. This is Lalita, your host for Mushrooms on Mars. This is the 11th episode. We're almost at the end. Finally, we're going to talk about mushrooms. The past 10 episodes have been about different plant growth systems on the ISS, the experimental Melissa project by ESA, European Space Agency, and mostly I spent so much time on it because I wanted to explain how important a closed loop system is, a closed loop life support system, and how challenging it is to establish something like that. Our biosphere, our Earth here, it was designed to be a closed loop system for us to live in a sustainable Earth. Nature designed it that way. Now, what we are going to do is mimic these conditions, especially for long space missions. ISS is just 250 miles above Earth. The longer space missions would be many, many years of travel. And pretty much there's going to be no pizza or salad out there in space. So it has to be, the space habitat should be a fully contained, fully sustainable, a renewable, closed loop life support system. That is the goal, right? So that's why we spend so many episodes without even talking about mushrooms. And finally, we're here. Now, I have to say, the last two episodes, I'm going to speak about mushrooms in space, generally, right now. And the last episode is going to be Mushrooms on Mars, the title of this podcast. And in subsequent seasons, we can go in depth into every aspect of growing mushrooms on Mars specifically. But before we do that, we have an idea of the challenges, the problems, the opportunities, and also the experiments that have been conducted on the ISS, so we know what is in the realm of possibility. And so far, we haven't done anything with mushrooms. And any experiment would be in a Melissa-like project, which is basically piloted on Earth. It's not yet been implemented in space. It's not implemented on the ISS, although I think some parts of it have been tested and implemented on the ISS. But mostly it is a project. It's an experimental project that is based out of Earth. So mushrooms offer a wonderful opportunity. We know what mushroom is, and we think of it as something like we add as a pizza topping or as a bisque, as edible. And now these days, mushrooms are used for medicine, like lion's mane and reishi. And also as medicine, psilocybin is being used as medicine for depression or anxiety. Now that's still in a gray area because I don't think all the states accept psilocybin as a drug. So that is a topic for a whole different podcast, which we will cover in the future in subsequent episodes. But for now, we're just going to speak about mushrooms in space. Okay, so there is enormous potential for fungal cultivation in not just space, but also in in a Martian environment. And that is what this episode is going to be about. So, just like with plants, microgravity is an issue. Just like with plants, they don't know which direction to grow, so they could be haphazard. And mushrooms are, they throw a curveball because they don't grow with seed, not by cuttings or any other kind of propagation. We know in the plant world, they are propagated by spores, spore distribution. But they also offer very unique advantages for space agriculture and life support system. So it combines life support system as well as food production, in a full closed loop system. So it hasn't been extensively studied like the Veggie or the APH to understand how they can play an important role in future space missions. But integrating mushroom cultivation into space habitats, it can actually work side by side and complement whatever we are growing in the plant-based agricultural system. So the main thing is it recycles waste while producing food. You know what I mean by waste. So there has to be a way. We can't just eject it out in space, right? So it also offers some medicinal benefits, and it supports the immune system. It supports cognitive functions. We know that about, I think, lion's mane especially. There's a lot of experiments being done on that. So the first advantage is closed loop systems. It can play a very crucial part because it can be a waste recycler. So it can even turn human waste into valuable nutrients. The second thing is they don't need sunlight for photosynthesis like plants do. That's another thing. You can grow mushrooms in a closet, in a drawer, in a table drawer. So these are things that makes you think, oh, it's more than food. What else can we do with mushrooms? So they also produce compost and substrates. The fungi has the ability to degrade even plastics and other synthetic material. And of course, we know about food. I'm not going to go into it. We will go in depth into every possible topic we can think of about mushrooms in space, and especially mushrooms on Mars in future seasons. So I'm just giving you like an outline of what is in the realm of possibility. Then, because they don't need sunlight, they require very low energy. So especially in space habitats where energy conservation is critical, it actually is a perfect fit. It has a very small space footprint. And of course, we spoke about medicinal uses. It can assist in drug design, and it can be integrated with existing systems like the Veggie system or the BioCulture system and the APH system. So in the BioCulture system, especially because in the BioCulture system we don't actually grow real plants, but we study how microgravity affects plant growth at a cellular level, at a biological cellular level. So when the system can be used to study fungal cells or mycelium. So the bioculture system is about cellular and tissue research. So mushroom mycelium behaves differently. We'll know that in microgravity. How does it act in microgravity? I remember this, that someone in a moment of questionable clarity said, are we growing mushrooms or are the mushrooms growing us? I have no idea where that question came from, but it made me think, because they grow out of organic waste, They're just like us. They take in oxygen and they give out carbon dioxide. And this, if you look into mycelium, it is so fascinating. There is a place in Oregon where there's the world's largest mycelium network, and it covers, wait for it, it covers almost 2,300 acres. I kid you not. So I have seen people making hats out of mushrooms. They make mushroom leather, as a humane alternative to bovine leather. It's called, I think, vegan leather. They can make leather out of mushrooms. I've seen, it looks like a felt cap. I've seen caps made out of mushroom. And it blows my mind what it is capable of. Do we even know mushrooms? I don't know. We have to dedicate a lot more episodes just to mushrooms on Earth before we go to mushrooms on Mars. So anyway, so you can also incorporate fungi in more complex growth systems like the APH, the Advanced Plant Habitat. So we can see how fungi interacts with the plant growth systems, because they can break down the waste, the organic waste from whatever plants we're growing, Because in agriculture, in my farm, when I grow something, yes, I'm growing tomatoes or, eggplants or even flowers. What I sell is only a small part of what I grow, So the rest of it, we make it into green manure, we mow it back, and I use a minimal till, no-till system. So whatever there is a green matter becomes a kind of living mulch to prevent weeds. So, and that works fine on Earth. But what are you going to do with all that plant material in space? We can't have like a compost bin on our space habitats. And mushrooms might be the answer. So for environmental management within this closed loop system, they would play a very crucial role. And the mycelium networks can be also integrated. They can also be integrated into the air filtration system, like meshes, like a filter to capture the toxins, or to help purify the waste streams. And but it's not that easy. There's a lot of challenges growing mushrooms in space. First of all, microgravity. So the effect of microgravity on the growth of mycelium. We don't know how mycelium would spread. And, we have to do controlled studies and figure out the growth patterns in space, which might be different than what we see here on Earth, mostly because of the microgravity. And of course, things like radiation, would the radiation make the mycelium, go rogue? It could be more dense, it could grow faster, or it could be stunted. We don't know yet. Water and humidity management is going to be an issue. They require very specific levels of moisture and humidity to grow. And they don't need a lot of sun, but its environment should still be managed properly. And then there's spore containment. So fungal spores are how we get mushrooms, right? So, but they can become a contamination risk. And so it has to be properly contained. So in space, because there's no gravity or there's microgravity, the spores can just float. So your entire spacecraft can be colonized by mushrooms if the spores are not contained, if there's not a containment system for the mushrooms. What I'm thinking of? I'm thinking of that Star Trek, the original Star Trek episode, Trouble with Tribbles. Just imagine, instead of tribbles. I don't know if I'm dating myself. Well, if you don't know what it is, just search Star Trek Trouble with Tribbles. You will know what I mean. So Instead of tribbles, it could be mushrooms that are colonizing the entire, spacecraft. You have to see that episode. You have to see that Star Trek episode to understand what I'm saying. I will stop there. But please do, if you don't know what it is, look it up. So, oxygen and CO2 exchange. Mushrooms have a respire like animals, like us. They consume the O2 and they release CO2. Plants, on the other hand, produce oxygen during photosynthesis. Plants also respire, but mostly they release oxygen and they take in the carbon dioxide. So that works perfectly with us. But when you bring mushrooms into the picture, even though they can be integrated into the closed loop system, you have to remember that you have to manage the air exchange system so that we are able to balance and actually know all the oxygen consumption levels and the oxygen production by plants and how much we are consuming. So this whole thing can be automated. I mean, like in my mind, I'm just like thinking, oh, how it can be like managed in a spacecraft. But definitely controlled studies. We have to study this. And, for all you know, we could have something like a torus, like a Stanford torus, and create like artificial gravity. We don't have to worry about any of this. But these are all theoretical concepts. And we always think, it's in the realm of science fiction. But I think it's the now. It is now that we should pursue these challenges and pursue space travel and pursue space colonization and go where no one has gone before, where no spore has gone before. So, yeah. So with that, I'm going to move on to our friends discussing the mushrooms in space. So let's move on.
Okay, buckle up, because we're diving into a topic that sounds like it's straight out of science fiction. But I promise you, this is based on some really wild research. Today, we're talking mushrooms in space.
It's funny. When we think space exploration, we usually think high tech, right? Like cutting edge engineering. But sometimes the most incredible solutions are right here on Earth, in nature.
It's true. I always imagine astronauts stuck eating that freeze-dried ice cream, which doesn't sound too appetizing, does it? But what if they could have fresh, delicious mushrooms grown right there on the spaceship?
Exactly.
That's the kind of future we're talking about today.
It's a future that might be closer than we think. And it all comes down to the fact that mushrooms, they're uniquely suited to the challenges of space.
So let's break that down a little. One of the biggest things we always hear about with space travel is how important it is to create a closed-loop system, right? Because you're essentially living on a tiny island where everything is limited, every resource is precious, and you can't just, get rid of waste easily.
It's crucial. And that's where mushrooms really shine, because they are nature's recyclers. Like, did you know that they can even break down plastic?
Right.
We're talking food scraps, plant matter, even things like space debris, which is a growing problem.
Wow.
Mushrooms can take all of that and turn it into valuable nutrients, which is perfect for creating a sustainable ecosystem in space.
Hold on, wait, they can break down plastic. That's incredible. So we're talking about sustainability, but that makes me think about food. Could mushrooms actually be a practical source of food for astronauts? I mean, could we actually grow enough? And are they nutritious enough?
Absolutely. Mushrooms are packed with protein, vitamins, minerals, a lot of things that astronauts are often deficient in, actually, on those space missions. Like, for example, astronauts often suffer from vitamin D deficiency because they're not exposed to enough sunlight.
Right.
Well, shiitake mushrooms, they're a fantastic source of vitamin D, even when they're grown without sunlight.
Wow. It's like having a little mini pharmacy growing in your spaceship. And speaking of pharmacies, I was fascinated by some of the research we were reading about the medicinal benefits of mushrooms, especially when it comes to the immune system. What can you tell us about that?
Yeah, so there's a lot of ongoing research in that area, but we know that mushrooms, like reishi mushrooms, which have been used in traditional medicine for centuries,
Right.
have these powerful immune boosting properties.
Yeah.
And that's something that's really important for astronauts because their immune systems are actually weakened by space travel.
Of course, yeah. Being out in space can't be good for your immune system.
It's incredibly stressful on the body, so anything we can do to support it is critical.
It's amazing, right? Like a natural way to help these astronauts stay healthy. And it's not just the immune system either, right? I was reading that there's also research looking at mushrooms and how they could potentially impact cognitive function.
Absolutely. That's another really exciting area of research. We're going to talk about mushrooms like lion's mane,
Okay.
which have been shown to have a really positive effect on cognitive function, memory, things like that. So you can imagine, like on these long space missions where astronauts are in this isolated environment for months on end,
Yeah.
being able to use something natural like lion's mane mushrooms to combat mental fatigue.
Right. To help them stay focused.
Exactly. That could be a game changer.
That's incredible. I mean, it's really remarkable. It's like these mushrooms are like little packets of, I don't know, like superhero potential or something, boosting your immune system, your brain power. But I have to ask, like this whole growing food in space thing, it's pretty mind-blowing in and of itself. But how do you even grow anything in space, let alone something like mushrooms, without sunlight?
That's the cool thing about mushrooms. They don't need sunlight to grow. They don't rely on photosynthesis like plants do. Instead, what they do is they actually break down organic matter, and they draw energy from that all in the dark. So you can kind of think of them like they're the ideal low-maintenance roommates, right? Happy to hang out in the dark.
I love it.
And while they're there, they're quietly transforming waste into these valuable resources.
Okay. That's brilliant. It's like they're like little spacefaring composters with a side of, superfood. So how would we actually make this work? I mean, we've got systems like Veggie, which is our current space garden, which is incredible.
Yeah.
But it uses a lot of energy for lighting, which is a precious resource when you're in space. Could mushrooms be a more efficient way to go?
For sure. So Veggie has been amazing for growing leafy greens in space.
Right.
But you're right, those lighting needs, they require a lot of energy. So for growing mushrooms, we could imagine a similar setup, maybe a smaller, more enclosed chamber, something that's specifically designed to cultivate those mushrooms.
Okay.
And get this, we could even integrate this system within or alongside Veggie.
Wow.
Imagine that would be maximizing efficiency.
So the mushrooms could be recycling waste from the plants in Veggie. You create this awesome closed loop system. And then in turn, the mushrooms are providing nutrients back to the plants, helping them thrive even better.
Exactly. It's like a perfect partnership, a symbiotic relationship that could really take our space farming efforts to a whole new level, both in terms of how much we can grow and how sustainable it is.
That's remarkable. It's amazing to think about. And it's not just about Veggie either, right? I mean, there's also BioCulture, which is being used for cell and tissue research up in space. Could that play a role in this whole mushroom-powered space future we're talking about?
100%. Remember we were talking about mycelium earlier?
Yeah.
The network of fungal threads.
Yeah.
Imagine using the BioCulture system to study how mycelium grows and adapts to being in microgravity. I mean, that could unlock incredible insights into how fungi in general are able to adapt to really harsh environments.
So we could use space as a laboratory to actually learn more about mushrooms.
Exactly.
Which could then lead to even more innovation, both for space travel and back here on Earth. It's like this amazing feedback loop of discovery. I love it. This is really amazing stuff.
It is. And we could even use bioculture to explore how different species of mushrooms adapt to things like radiation, microgravity, all those unique stresses of space. And potentially, we could even use that knowledge to develop tougher, more resilient strains of mushrooms.
That we could then use for all sorts of applications.
Exactly.
It's really incredible to think about. So we've talked about mushrooms as this amazing food source, this incredible recycler, an immune booster, a potential brain power enhancer, all while pushing the boundaries of scientific research. I mean, it sounds like something out of Star Trek.
So right.
But it's becoming our reality. So where do we go from here? What's next for this whole field of mushrooms in space? You know, it's funny. I used to think of mushrooms as just something you put on a pizza.
Right.
But after this deep dive, my mind is blown. They're like these hidden heroes of the natural world.
Totally.
With this incredible potential, not just to help us explore space, but even to live more sustainably here on Earth.
You got it. And I think that's what's so exciting about this whole area of research. It's not just about fixing problems we already have. It's about changing the way we think about solving problems, especially in these really extreme environments.
Right.
Nature has already come up with so many incredible solutions, like these fungi solutions we probably haven't even dreamed up yet.
Absolutely. It's like we're on the verge of this whole new frontier of scientific discovery.
Yeah,
And mushrooms are leading the way. This has been an incredible conversation.
it really has.
So as we wrap up, what's the one big takeaway you hope our listeners are left thinking about today?
That's easy. The next time you see a mushroom, maybe it's on your dinner plate or out on a hike,
Yeah.
just take a second to really appreciate it. Because these incredible organisms, they have the potential to completely change space travel, make us healthier, and inspire a whole new wave of sustainability.
It's true. They really could change the world.
The future is fungal, my friend, and it's looking brighter than ever.
I love it. That's a great way to end it. Thanks for joining us on this deep dive into the incredible world of mushrooms in space.
My pleasure.
For the deep dive, I'm your host.
And I'm Expert's Name.
Until next time, keep exploring.
Oh boy. So we are at the end of episode 11. As usual, if you go to jelliclesfarm.com and look under mushrooms on Mars, you can see the material that I've collected for this. It is not something I can discuss in one episode. In subsequent episodes, maybe in the next season, I'm going to break it down, like every single aspect, like how we grow from spores to microgravity, like what are the different systems we can use. But it is going to be specifically for mushrooms on Mars. Long distance space travel, not just to the ISS, okay? So the ISS is just, it's in the low Earth orbit, it's close by. And it is a completely different ball game when we think of space travel. It is a completely different ball game when we think of a full closed loop system, a full closed loop life support system. So that would be where mushrooms will play a really important part, because we have to think long term, and it's not just like picking up a couple of mushrooms for your pizza. So I'm really excited about that. But even so, the next episode, the last episode, is just going to be like a spark that I want to introduce to get people thinking about it. So we'll be having a couple of events. The purpose of this podcast is to have real-time, in-person meetings or where we can brainstorm. It's going to take a lot of brilliant minds to solve this, to just solve food production in space, but including mushrooms and thinking about closed loop systems and a full closed loop life support system. It's something more, it's more involved, it's more complex, and it is a problem to solve. And we love problems because we love thinking about solutions for it. So the purpose of this whole exercise is to create little hubs where people can meet in person, make friends, and like-minded people who can figure this out, and you should all love mushrooms. You should love mushrooms as much as I do, at least, if not more. So that'll be something. I think it's already too late. I don't know why we haven't really delved into mushrooms on Mars or mushrooms in space, but better late than never. So on that note, I'm going to close this room for now, and see you for the last episode.